Welcome back. Unfortunately, I have run out of free AI voiceover credits, so you're stuck with me for the rest of the course. In this video, we're going to scratch the surface of spatial data and methods. Spatial analysis has been used to do all sorts of things in agriculture, and agriculture generates a lot of data. If you take a deep dive into spatial data, you'll find that similar to time series data, spatial data does not always fit the Gauss-Markov assumption of independence. You'll also find that sometimes location matters, and you want to pay attention to that. Spatial data is simply data with a spatial component. That spatial component can be in the form of vector and raster types. Vector data represents features using points, lines, and polygons, while raster data is structured as a grid of cells, providing a different way of representing information. Spatial resolution refers to the level of detail in a spatial data set. Higher resolution means more detailed information, but may result in larger file sizes. Georeferencing is crucial. It's the process of spatially locating the data. This enables seamless integration with other spatial data sets and is fundamental for meaningful analysis. Where can you get this sorts of data? What are the sources of agricultural spatial data? Well, satellite imagery is one place. Satellites play a key role in capturing large-scale agricultural landscapes. Satellite imagery offers regular coverage and historical data, providing a broad perspective. Unmanned aerial vehicles, UAVs, or drones provide on-demand, high-resolution data. Their flexibility in flight patterns makes them valuable for precision agriculture and monitoring smaller areas. Sensor networks contribute real-time data on environmental factors. These networks are integral to precision farming, enabling timely and targeted interventions. And field surveys. Field surveys involve ground-based data collection. They provide specific, localized information and are essential for validation and calibration of remotely sensed data. So what are some challenges with using spatial data? Data heterogeneity arises from varied sources and formats. Standardization and data integration techniques are crucial to manage this diversity. Some scale challenges. Spatial data comes in different scales, and that can impact the analysis. Sometimes you'll find yourself needing to adjust the resolution of imagery you are working with so that it's all on the same scale. Understanding this and addressing scale challenges are important for accurate spatial interpretations. And finally, a very common problem is missing spatial information. So incomplete or missing spatial information is a common challenge. And strategies like interpolation or data imputation are important. Moran's I is a measure of spatial autocorrelation, or how correlated a variable is with itself over space. It is a tool that can be used to scientifically find and quantify spatial patterns. The Moran's I can take a value from -1 to 1 with values close to +1, indicating that there's a positive spatial relationship, or being near a phenomena increases the likelihood of the phenomena in near places. Like wild pigs tend to have known presence near other wild pigs that have wild pig presence. And -1, indicating a spatial relationship that is the opposite. So being near something decreases the likelihood of that phenomena nearby. Maybe like a solitary animal with a wide range, like some kinds of big cats. A result close to 0 indicates there may not be a spatial relationship. Let's consider an example for Moran's I. I've done research on wild pigs. This is a county level distribution map for 2012 where known presence is in red and no known presence is in gray. We might ask ourselves if this distribution is random or if there's some spatial process in play. For this to be meaningful, for a minute, we need to assume that no known presence is actually no presence. So we need perfect observability. If we do that, we can calculate Moran's I and find it to be 0.751. Okay, that's close to 1, where we have a positive relationship. But is this really different than 0? The bootstrap approach for a hypothesis test demonstrated here would suggest so. 1,000 simulation bootstrap test with a p-value of 0.001 says we have evidence to suggest a positive spatial process is in play. Maybe we already understand that location matters and we want to know how much, or we just want to control for location. Here we have generated several points on a map with a soil nutrient level and a crop yield that is a function of that nutrient level. It might be instructive to calculate our mean yield in a way that gives us a mean for a place with decreasing weight on places that are far away. Geographically weighted summary statistics provide the tools we need for this and more. I mentioned that yield was a function of soil nutrient levels. That relationship might be constant across space. That would be the LM call above the map on the slide. However, we might find that location matters once again, and that our coefficients should vary across space. Now, the validity of this method is actually a bit controversial. So if it's something you want to use professionally, you're going to want to take a deep dive into that controversy. For the rest of you, carry on like this is gold. Geographically weighted regression lets us have different coefficients for different places. In this relationship, if I would have observed different coefficients over space, I would think we were not accounting for something in the analysis. However, something like home values as a function of bedrooms, it really could just be that bedrooms are worth different amounts in different places. Agriculture is tied to the land, and that means location sometimes matters. When it does, these tools help us do a better job of understanding the relationships we need to understand and predicting the things we need to predict, whether that is in the policymaking or decision-making space. This is a big topic, and normally it would be a course in itself. This exposure should help you get started if you need to use the tools so that you can learn what you need to learn.